Ethereum is a blockchain platform designed to be a next-generation decentralized application environment. Its white paper, authored by Vitalik Buterin in 2013, introduces Ethereum as a generalized blockchain system that extends beyond simple peer-to-peer transactions of digital currency. While Bitcoin proved that decentralized value transfer without intermediaries is possible, its scripting capabilities were limited and not flexible enough to build complex applications. The Ethereum Whitepaper proposes a protocol and platform that supports a fully programmable blockchain through smart contracts and the Turing-complete scripting language. The goal is to create a decentralized world computer where developers can deploy applications of any kind without centralized control. The whitepaper begins by identifying limitations in Bitcoin. While Bitcoin transactions can include small scripts, these are restricted to basic operations such as multi-signature wallets, time locks, or hash commitments. More advanced use cases such as decentralized exchanges, lending platforms, or governance systems are not feasible within Bitcoin's scripting design. Ethereum addresses this limitation by embedding a virtual machine directly into the blockchain, allowing arbitrary code execution and state management. This Ethereum Virtual Machine, or EVM, enables developers to write and deploy smart contracts in a flexible and secure manner. A smart contract in Ethereum is essentially a piece of code that lives on the blockchain and executes automatically when triggered by transactions. Smart contracts can store data, send and receive value, and interact with other contracts. They are deterministic, meaning that given the same inputs, they always produce the same outputs, ensuring consistency across the decentralized network. Because they are deployed on the blockchain, smart contracts are immutable and censorship-resistant, providing a foundation for trustless applications. The white paper envisions a vast ecosystem of decentralized applications, or DApps, that can operate on top of Ethereum without reliance on centralized servers or intermediaries. The white paper defines Ethereum's core design as a blockchain with a built-in programming language. Blocks in Ethereum contain not only transactions but also contract code and the state of accounts. Accounts are of two types: externally owned accounts, controlled by private keys, and contract accounts, controlled by their code. Transactions can either transfer value between accounts or trigger contract execution. When a transaction invokes a contract, the Ethereum Virtual Machine processes the code, updates the state, and records the results on the blockchain. To manage computation on the network, Ethereum introduces the concept of gas. Gas is a unit of computational effort required to perform operations, from simple value transfers to complex contract execution. Every transaction specifies a gas limit and the gas price. The gas mechanism prevents infinite loops and denial of service attacks by ensuring that every computation has a cost. Users pay for gas in Ether, the native token of Ethereum, and miners receive these payments as part of transaction fees. Gas thus aligns resource usage with incentives, ensuring that the system remains efficient and secure. Consensus in Ethereum was initially based on proof of work, similar to Bitcoin, but with shorter block times of around 15 seconds. This allowed faster confirmation of transactions and improved responsiveness for applications. The white paper also outlines the eventual goal of transitioning to proof of stake, where validators secure the network by locking up tokens rather than performing energy-intensive computations. In later years, this transition became known as Ethereum 2.0 and culminated in the merge, but the original white paper already recognized proof of stake as a more sustainable long-term solution. The white paper provides examples of applications that could be built on Ethereum. These include token issuance, where users can create custom assets that run on Ethereum, decentralized organizations, where rules are encoded in smart contracts, financial contracts such as options or derivatives, identity systems, supply chain tracking, and prediction markets. The key point is that all of these use cases can be built on the same underlying platform without modifying the base protocol. Ethereum is designed to be general purpose and adaptable, unlike Bitcoin, which is optimized for digital cash. Security is another major focus of the white paper. Smart contracts introduce new risks, since errors in code can lead to unintended consequences. The immutability of blockchain makes it difficult to fix bugs once contracts are deployed. The white paper acknowledges these risks but argues that the benefits of programmable trust outweigh the challenges. By designing a flexible system with clear economic incentives, Ethereum seeks to create an environment where innovation can flourish. Over time, developer tools, formal verification, and auditing practices have evolved to address security concerns. Ether, the native cryptocurrency of Ethereum, serves multiple roles. It is used to pay for gas, incentivizing miners or validators to process transactions and execute contracts. It also acts as a store of value and medium of exchange within the ecosystem. The issuance of Ether follows a predictable schedule, and block rewards ensure that network participants are compensated for their contributions. In addition, Ether is essential for governance and protocol upgrades, as holding it aligns the interests of users with the health of the network. The Ethereum Whitepaper emphasizes decentralization not only in money but also in applications, governance, and infrastructure. The idea is to reduce reliance on centralized platforms and create a level playing field where anyone can participate. By enabling programmable contracts, Ethereum envisions a decentralized Internet of Value and Services, sometimes referred to as Web3. This vision extends beyond finance into social, political, and organizational systems, making Ethereum a platform for experimentation with new forms of coordination and cooperation. In summary, the Ethereum Whitepaper introduces a blockchain platform that expands the scope of decentralized technology from simple value transfer to general-purpose computation. With its virtual machine, smart contracts, gas mechanism, and economic incentives, Ethereum provides a flexible foundation for decentralized applications of all kinds. It addresses the limitations of Bitcoin by making blockchain programmable, while retaining the trustless and decentralized principles that make the technology revolutionary. Since its publication, Ethereum has grown into one of the most significant platforms in the blockchain space, powering decentralized finance, NFTs, DAOs, and countless other innovations. For more insights on Ethereum, smart contracts, and decentralized application platforms, remember to like, subscribe, and keep learning here at Crypto in Black and White.